Hi guys, for this topic, for this video's topic, we're going to discuss about momentum. Momentum is very important computational calculation, especially in car crash or accidents. So what is momentum? Momentum is a product of mass and velocity of an object. So if there is a mass and a velocity, it's like a car moving forward, so that is actually there is a momentum building up on it, and the momentum has a formula equals to mass times velocity as specified in the description. So momentum is uh, will have a symbol of p, so and mass and velocity, and the unit is either the basic unit, which is kilograms meter per second, and Newton second. So if you're going to analyze this one, Newton is kilograms per meter squared. Okay, so if we're going to multiply seconds here, then we'll crash out 1 seconds and eventually we'll go back to kilogram meter per second. Linear momentum. So for example, how big is the momentum of a child of mass 25 kilograms walking at a velocity of 0.38 meters per second? So applying our formula for momentum, P equals to mv, and our m is 25 kilograms times the velocity of the child walking. So it will be equal to 9.5 kilograms meter per second, or 9.5 Newton second. So another example, what is the momentum of a Eurostar train of mass of 650 tons moving due south at a speed of 60 meters per second? So same thing, apply our formula, and here the first thing you need to do is convert your unit. The given is in ton, so you need to convert that to kilograms. So 1 ton is actually 1000 kilograms, so that's why we have an answer of 650,000 kilograms times the velocity. So the answer would be 3.9 times 10 to the 7 kilograms meter per second, or 3.9 times 10 to the 7 Newton seconds. Collision. Collision is the event in which two or more bodies exert forces on each other. So it's like stationary, maybe a stationary one, or two cars moving at each other, towards each other. And this collision is actually conserved. So collision is in relation to momentum, and it is actually conserved. For example, a loaded supermarket trolley of unknown total mass is rolled into a stationary stack of two empty trolleys of, of mass 8 kilograms. The speed of the loaded trolley before they link together is 2.2 meters per second, and the speed of the linked trolley after the collision, take note, after the collision, is 1 meters per second. So the trolley with loaded with supplies that's being loaded in the trolley before it collides with the stationary one has a speed of 2.2, and after the collision the speed reduces down to 1 meters per second. So let's say you have this one, so it's like colliding to each other here, colliding to the wall. Alright, so answer, you need to use the fact that moment is conserved. So therefore, moment before collision is equals to moment after collision. So how are we going to answer that? So first, moment before collision. So we have here, we are actually asked for the mass of the shopping or supplies that's being put in one of the trolleys before when it is pushed towards those trolleys that is stationary. So we have the mass of shopping. So these are the masses. We don't know. This is actually the one that you're going to calculate. Plus the mass of the trolley. Without the without the trolley, those we cannot actually put the supplies. So that's why we have the mass plus the mass of the trolley times the speed. We have the speed here. So that is going to be here. So we have our mass, so take note that our momentum unit is kilograms times meter per second. So we already have our mass, which is this one, and our speed, which is 2.2. So we have our first moment, so the moment before collision. The next one is the moment after collision. So we have, of course, the mass of the shopping, and then the masses of the trolley. Take note, we have two empty, two empty trolleys. So two empty trolleys, each will having a mass of 8 kilograms. So if we have two empty trolleys, that would be 16. But after the collision, we already have three. So 16 plus 8 will gives us 24. So that's why we have m plus 24 kilograms. Then multiply it with our speed after the collision, which is 1 meter per second. Okay, continuing our solution. So multiplying our speed there, multiplying our speed there. So we have 2.2 m, and we have 2.2 times 8. So that's why we have it here. Same thing as with in the other side. So there and there. Okay. Next one, simplify. You will have those values. So the next one is you combine like terms. So this one you're going to put it here. So when you transferred this to the other side of the equation, it will become negative. So technically this is actually positive. So when you transfer it across the equal sign, it will become negative. So same goes here. You transferred our plus 17.6 to there. So that's why it becomes negative. Okay. So to simplify, we have 1.2 m equals to 6.4. Okay, so to continue our calculation, so m equals to, so you cross multiply our 1.2 here, so that's why we will have 6.4 divided by 1.2. Then finally our answer is 5.33 kilograms. So another example, an arrow of mass 120 grams is fired into a block of wood with a mass of 0.6 kilograms resting on the wall. The arrow and the wood fly off of the wall at 8 meters per second. So calculate the speed of the arrow. So for example, this is our arrow and the wood. So just an example for you to see. Okay, so answer, same thing, using the momentum as being conserved. So momentum before collision and momentum after collision. So we have the mass before the collision or the momentum. So we have momentum before collision, which is the mass of the arrow. Take note, when we are going to solve momentum, the unit is in kilograms. Our given is grams. You need to convert that to kilograms. And then the velocity. We don't know the velocity actually. And we have here, so when it hits the wood, it will be the arrow plus the mass of the wood times the speed, which is given after the collision. Okay, to continue the calculation, so cross multiply, you will have this one, 0.72 kilograms divided by 0.12 kilograms times 8 meters per second. So therefore, the speed of the arrow before it hits the wood is 48 meters per second. Okay, so that's conclude our discussion for momentum. So if you have any questions or clarification, please leave a comment below and have a great day.